Welcome to this tutorial. In this video I'm going to teach you the basics of FreeCAD for 3D printing. This also includes modeling an actual object which you can 3D print and then use in your daily life. By the end of the video you should be able to model your own ideas and print them. Now FreeCAD is open source, which means everything what you create with it you can also use commercially. You don't have to pay anything, and you also have access to the source code which is available on GitHub. FreeCAD is available for Windows, Mac and Linux, and also for Apple Silicon. Alright, enough talking. Let's dive into FreeCAD. Once you have installed it on your system, I'm right now here on Windows 11, you should see a similar startup screen like this here. Now here in the bottom right for this video you will see my mouse and keyboard input. And a left mouse click is marked with an orange circle. A right one is marked with a blue circle, and a middle mouse click is marked with a yellow circle, similar to Portal. Now in this dialog, we can choose between the light theme or the dark theme. I'm going to use the dark theme, and we can also set the navigation style. I'm going with the Blender navigation style because I'm used to it, but you can also go with Tinkercad or something else. Then we set also the unit system. I'm going with a standard one with millimeter and kilogram, and we can also set the language. Then we hit on done, and we have another start page here with a few example projects. Those example projects are pretty useful to get an idea how a typical FreeCAD project is structured. So let's have a look at that, at this part design example here. Just double click, and then you can also see at the bottom that it opened up a new tab for this project. We can also go back to this start page and we can open another project. Let's open the engine block. And this also opened up another tab. And we can quickly switch between the projects by clicking on the proper tab. Let's close this engine project for a moment and let's focus on this one here. If you accidentally closed the Start tab, you can always open it up by going here on the top left to Help and click on Start. Let's have a look at the navigation here in the 3D space in FreeCAD. I can do my typical actions like rotating in and out, and also by clicking the middle mouse key, rotating my object around. And I also have this navigation cube here in the top right, where I can select which of the sides of my object should be shown, like the front side or the edge between the front side and the top, or even the corner. I can also simply use those arrow buttons here. And I can also rotate the object by clicking on those longer arrows. And this circle, if I click on it, it always will show me the opposite side of the object. This little cube here is another menu. If I click on it, I can switch to another view. Right now we are in the orthographic view, and I can switch to the perspective view. And there's also the isometric view. And right now you can see if I rotate my object around, the point at which this object is rotated is marked with a red circle, with a red sphere. And right now it's a bit inconvenient because it always rotates where I click with middle mouse key. But we can simply change that. We have to go to Edit, Preferences, then we go to Display and Navigation. Under Rotation Mode, we set it to Object Center, which means it will always rotate our object at its center. So if we are now rotating it, it's rotating at the center of the object, which feels a lot more convenient. Also, if we hover over a face and press the middle mouse key, it will set the rotation point there. The same goes for if we are hovering over an edge, then it will rotate around this rotation point at the edge. Similar to Blender, I can also rotate my object by using the numbers on my numpad, but here you change it by simply using the numbers from 1 to 6. You can move. And you can change the draw style of the object. Right now it's solid, and if we do a right click on the object and select draw styles, we can select points. This will only render the vertices, and it's barely visible. We can also just render the wireframe, hidden line, so we only see the polygons, no shading, shaded, and flat lines. This seems to be equal to the first one. Here on the left, we have the hierarchy. And if I hover on this body object here in the hierarchy, it makes my object kind of transparent. Now it's crucial to understand how this hierarchy works because it's a lot different than in Blender or like in Photoshop. This body represents one single solid object. Inside of the body, I have a history of tools and operations I have used to create this object. What I can see here are not individual objects. Those are individual operations and tools. And it starts from top and goes to the bottom. So here at the bottom, I can see the most recent action, which is also visible right now. If I make my previous action visible, I can see that my object has simplified. So I'm missing the latest step, which was creating like those cutouts here. And if I select this pocket operation here, my object is even more simple because I'm missing those two last steps here. And it all started with the first operation, which is a padding. And this padding uses a sketch. In FreeCAD, your models always start with a two-dimensional sketch. So let's have a look at that. We simply double click on it. And here in the sketch, we simply define the shape, how our 3D model should look like. If we finish with this, we simply add a padding operation to it, and then this pocket operation is added to it. It also uses another sketch. Each operation needs to use an additional sketch, and this is independent from the previous sketch. This third step is using its own sketch, so it's creating this circle, and with this circle, the pocket operation creates this hole here. The same goes for the last operation, which uses another sketch to create those cutouts here. The advantage of having this history is that you can always adjust previous operations that you have done on your object. For example, if I want to change the size of my object here, then I can simply change the parameter. And I do that by changing the parameter of the constraints. The constraints are basically rules which say one side can only have the length of, for example, 40 millimeter, or in this case here, the circle has a radius of 35 millimeter. It only can be like that. If we try to move it around or do some other operations, we can't do anything. We could do that by simply removing the constraint. Now this circle has no constraint anymore, so I should be able to increase the size of it. Now I click on close here. The changes of my sketch have also been updating the entire model. One thing to keep in mind if you're doing some changes to previous steps in your hierarchy is to keep them as simple as possible. And by that I mean focus your changes on the adjustment of parameters like the length of a side or the diameter of a sphere. You can also do some small adjustments to the shape of your sketch. Otherwise, there's a high chance your model can break, and that's because of the topological renaming issue. From my understanding, all CAD programs are sharing this issue, and there's also a detailed page on the documentation of FreeCAD, which I'll link in the description. So to summarize, that basically means you should invest a bit more time in planning your modeling steps before doing them, so you can prevent unnecessary changes. Let's have a look at the workbenches. Here on the top left, we have our workbenches. Workbenches are simply a collection of tools for a specific use case. You might have notice if I double click on the sketch of any sketch, then my workbench is also changing and I have a different set of tools. If I click here on close, I'm back at the part design workbench and I have again another set of tools. Now, as you can see, we have here a lot of workbenches and this can be quite intimidating. For 3D printing, we basically only need 3 of them, and that's the sketcher, the part, and the part design. To improve our workflow, we can actually change how this here is rendered. I prefer that those workbenches are rendered here in a row instead of this drop-down list. So I will go to Edit, Preferences, Workbenches, and here I also can set which of those workbenches will be shown. And like I said, we only need 3 of them. We will need sketcher, then part and part design, and we won't need the rest of it. Under workbench selector type, we select tab bar. And then we can also choose if the workbench button is rendered with icon and text or only icon and or text. I prefer to have the icon and the text. So I hit on apply. Okay, and then I need to restart FreeCAD. Once restarted, you can see that I have all my workbenches here in a row. It can happen that you can't see any of those tools here in this bar, and for that you simply have to right click on this gray bar and activate everything which belongs to this workbench. So in this case, we have opened up the part design workbench. We need to activate everything which is also called part design. The same goes for the part workbench. Well, in part workbench it's a bit different. There we simply need to activate Boolean, part tools, solids, and in Sketcher is a bit different because to open up the tools of Sketcher we actually need to open up a sketch. So we double click on any sketch here in the hierarchy and then we get access to all the tools. And if you don't see any of those tools, you have to go to the bar again, press right click and activate everything which has Sketcher in the name. Now about switching the workbenches, if I now want to go back to the part design, you can see that my tools of the part design are still grayed out and apparently I'm still in the Sketcher workbench. This is because I haven't finished my tasks here. I always need to finish them first before switching to another workbench. So I simply click on close and then I'm in the part design workbench. The same goes for the part design workbench and also the part workbench. If I want to edit this padding operation and I go to the Sketcher workbench, I don't see anything. I have to finish this first, then I have access to the tools. The Sketcher workbench is, like I said, a bit different because I have to open up a sketch first to get access to the tools. Now we have pretty much covered all the basics for navigation here in FreeCAD and we are ready to create our own project. To demonstrate the use of FreeCAD on a real-life example, I want to create something which improves my daily life. So I'm right now here in my kitchen and I have here 2 bins for waste separation. So this box here is from IKEA. I will put the exact model of it in the description. And if we take a closer look, it has those 2 holes here. And the basic idea is to create a mount where we can put this box on top of it. This mount can be also placed here on this door. And so we can mount this box to the door. And every time if we open it, it will be very easy to access and it will also make this bigger bin easily accessible. Let's quickly measure those holes. So I will measure them with this cheap caliper. So let's first start it, set it to 0. It's a bit difficult to measure them because everything is so small here and this caliper is quite big. But I will use the bottom side of it to measure the depth of those holes first. So the depth is like 13 millimeter. The width is like 18 millimeter. Now the height of the holes is a bit difficult to measure, but I will also use the bottom of this caliper again. 6.5 millimeter minus the wall thickness of this here. This might be like 2 millimeter. So it should be like 4.5 millimeter height. Then we also have those hinges of the top plate here. And they are like
10 millimeter thick. So let's create this first prototype in FreeCAD.
So now I'm going to create a new project and I'm going to create the mount for the bin. And while I do that, I will also explain the individual tools we are using for each workbench and how they work. So basically learning by doing. So first we close this project and then we create a new one. Simply click here on parametric part. You can also create a new project by going to file and then new, but this will create a project without a body. And every model which we want to print needs at least one body. And this here will automatically also create the body for in our project. So here I have my body and also the origin object. This is basically the object which shows all the planes for each axis. Now we can create our sketch. So I go here in the top left and select create sketch. And I can either select my plane on which the sketch will be applied here in the 3D space or here on the right in the tasks section. So I'm going to choose the XZ plane and then it automatically switches to the sketcher workbench and it also has created the sketch here in the hierarchy. Now here on the right, I will enable the grid, toggle grid. The grid is only available in the sketcher. It's not available in the part design. And now I can make my origin object invisible again because I won't need it further. And I make my sketch visible and then I can start creating the sketch. Most of the time you are going to use only a handful of those tools. To create a circle, you can simply use this tool here, or also the rectangle tool to create any kind of rectangles. Same goes for hexagons or polygons. And if you want to create your own shape, which is not available here, you use the polyline. This allows you to create any kind of shape. And like I said, the mount will have the look of an S. So it's an S-like shape. So I will have to create it by my own. So I will start here and I will draw the first line. And you can see it also shows me the length of the current line. And what it also does, if it's vertical or horizontal, it shows those additional lines. It will automatically add this constraint. This is a constraint for vertical or horizontal lines, which means those lines can't be angled. They can either be horizontal or vertical. And I have to make sure that I click here on this vertex to connect the edge. And now I have a fully closed shape. And what I'm going to do as next step is I'm going to add the constraints. First, I do a right click. With the right click, I always deselect my current selected tool. With the constraints, I simply tell that the parameters are fixed for this shape. So if I add a constraint to this edge and I set the length to be like 130, it means it can't be changed anymore. You can see here on the right, it says this shape is under constraint. And the goal is always to fully constrain your shape, because this way you can prevent any accidental modifications. So let's begin with the constraint for this line. So the tool for the dimensions, they can be found here in this drop-down menu. We have to use it quite often. It's kind of annoying to always open up this drop-down menu, but we can change that. So we go to Edit, Preferences, Sketcher, and then under dimensioning constraints, we set separated tools, click on apply and OK. Now we need to do a restart. So let's first save this project. And now I'm going to restart my FreeCAD, save. And after the restart, we can see that we have those dimension constraints here separately, which makes our workflow a lot easier. So let's add this constraint here, 130 millimeter. You can also move it around. So just left click and hold it. And you can also move it like this. Then we need also a constraint for here. We wanted to have a thickness of 4 millimeter. So we're going for this constraint distance. For that, we need to select, so first the vertex, then the edge, and then we set 4 millimeter. And here it's a bit unreadable, so I move it like this, We do the same for here. So we click on the vertex first, then on the edge, 4 millimeter. The same for here. Vertex first, and then edge. This kind of constraint is if you want to have the thickness or like the distance of, in this case, 4 millimeter, independent from its angle. Same goes for this here, 4 millimeter. For this here, you can actually also do it in a different way, at least for here. You can simply set the horizontal constraint. Okay, this one actually has to be different. It's like 4.5 millimeter. And then we need to set the constraint for this here, 20 millimeter. And you can see it also adjusts the whole shape automatically. I'll move this here to the left. You can still read the measurements. And what are we missing? If you're unsure what constraint you're missing, you can always try to move your object around. Then you can actually see what is missing, because everything which increases in size, those parts don't have a constraint. So here I need the horizontal constraint. So this should be like 13 millimeter. Actually, this one should be 13 millimeter. And now what we are missing is only, now we need to add the constraint to the bottom, because this one is 70 millimeter. Right now the shape is actually fully constrained, but we can still move it around because it has no reference, and we set the reference. So we say I will choose this point and then basically the point 0, 0 in this grid. And I'm going to say this should be like 5 millimeter. Where is it? 5 millimeter. Okay. I still am missing one. Yeah, it's this one here. Okay. Yeah, so we also have to add a constraint here. Yeah, 10 millimeter is fine. And then we can see the shape is green now. And it also says here it's fully constrained. Let's adjust the position of the measurements so it's more easy to read. Awesome. Now let's have a quick look at the other constraints. Sometimes you are going to use this constraint equal. You can use that if you have a rectangle and you want both sides of the rectangle to have the same size, then you can add the constraint equal. So you have to select it and select the edges afterwards. Then here you have the constraint parallel, which does what it says. If you have two edges and you want to have them parallel, you just add this constraint. No matter how they are angled, after you've set this constraint, they will be parallel. Those are the constraints which are added automatically if you are creating vertical or horizontal edges. So you can see here, this is the vertical constraint and also the horizontal one. If it's not set, we are deleting it, then you could move this around, and now if we add it back, it can be only horizontal, so pretty easy. Then we have also the angle constraint, so that we delete those ones here, and then we can add the angle constraint. So I select this edge and this one, and then I can set my angle. So in this example, it doesn't make any sense. If you have a triangle where you want to have a specific angle on one of the corners, you can use this angle constraint. Same goes for the circle constraint. So you can set a fixed radius or a fixed diameter, and that's basically all you need to know for the constraints. So we are going to remove this again. So now it's fully constrained, save. Then we need to close it. Now we are automatically back in the part design workbench, and we are going to create a 3D object out of it by adding padding, by adding some padding to it. Now you can see in the hierarchy, it added this pad operation object, and inside of it, we have our sketch. Now I can adjust the dimensions of my padding, and I want it to be like 35 millimeter. Okay, that's good. To mount my box here on it, I need an additional gap. So I create another sketch, and this time it needs to be also on the XZ plane. And for this one, I actually don't need any constraints because it's a simple rectangle. Then I click on close. And what I haven't mentioned yet is also you can adjust the position of your sketches. For that, we have here under our hierarchy some options. We have here this option attachment, and under attachment we have position. And there we can adjust the position of our sketch. Right now it's on the XZ axis with 0 on each axis, and we can move it slightly to the Y axis. So we actually wanted to have it here in the middle to create a hole. So our thickness of this object, of this padding object, is right now 35 millimeter. We should move it in the middle. That's 70.5 millimeter. Okay, that's, I don't know why this is not moving it on the Y-axis, but on the Z-axis instead. Okay, this is correct now. So it's here in the middle. And we can use the pocket tool, the pocket operation, to create our hole. I want the hole to be, or the cutout to be like 2 millimeters thick, and I want it to be symmetric to the plane, so it's perfectly in the middle. And then I hit on OK. What I also want to do is, this is quite a large plane, a large object, which can really increase the print time, and I don't think I will need all of this to have like a stable mount. So adding like a hole here would also be beneficial and reduce my print time and the material. So let's create another shape, this time on the YZ plane, and we are going to use the rectangle tool and draw our rectangle. Activate the grid again. In this case, it would be beneficial to see like the wireframe. So let's switch to wireframe. Okay, let's first close it, go back to part design and select wireframe. Perfect. Now we double click on our latest sketch here. All right. And then I'm going to create another pocket. And here is our pocket object in the hierarchy, and the sketch is inside of the pocket. And then we need to adjust the length of it. So let's set it to 10 millimeter. Now nothing has happened. I think we need to reverse it. So double click on the pocket again and reverse it. And there we have our hole. So I will change the draw style again to as is. It needs to be a bit longer, maybe 12 millimeter. Yeah, 12 millimeter. And then we have our hole. So that's it basically. I will now do some adjustments to it, improve the dimensions and check if everything fits, and then I will show you the final result. But so far, this is basically the workflow how you can create your own models in FreeCAD, which you can then 3D print. And in the end, you only need to export it. So you go to File. So first, let's save it. Go to File, Export. We have to select everything first, and then Export. We select the STL format, and the STL we load later into a slicer, and the slicer will create the G-code, and then we can simply print it. This is the updated design. As you can see, I added some cutouts. I reduced the distance here, and I added also some rounded edges. Now those cutouts, obviously they reduce the printed material, but they actually add print time because they are more complicated to print. I was thinking what kind of shape could I use for a pattern. I decided to go with this one because I can print it without any support structure. And also it kind of looks cool. So let's first have a look at the sketch. In general, I adjusted the size of it, so I made it 135 millimeter, and I did some adjustments here at the bottom. So as you can see, I added 2 angle constraints. So simply by selecting the angle constraint and select the edges afterwards, and then I can set the angle. Same goes for here. And I also added a parallel constraint. This is the one. And with that, because those edges are angled and I want them to have the same width at any point, so you can simply select the parallel constraint, and like the angle constraint, you select the edges afterwards. So like this, we can, just for demonstration, we can remove them, and that way they can be like, they can have like different angles. And if I set the parallel constraint, they will have the same width at any point. So those were the changes for the S-shape sketch. Let's continue with the third sketch. So here we have a hexagon, and I created this hexagon by using the hexagon tool. And you can simply create any kind of hexagon. If you press Ctrl, it is a fixed step size. If you click again, it will create the hexagon. And here we can see a lot of constraints. So we have here a circle constraint. We can simply delete that. I simply adjusted the constraint to my liking. And what is also new, you can see here this yellow face. And what this is a shape binder. So if we go back to the part design, it will simply close this. Then we can create here shape binder. This is basically to create a reference from one sketch to another object or to another sketch. So I wanted to have my sketch to be referenced on this plane of the padding operation. So I was simply selecting that for the face, and then I clicked on this shape binder, and this will create a new object. And now in my sketch, so let's double click on it. There's a tool called Create External Geometry here on the top in the middle. And I also have to make sure that my binder object is visible. And then I simply select the edges. So simply by left clicking them on each side. And then I have created my reference. And it looks like that. Those purple lines are my reference, and with that I can set a constraint. So you can see here I've set a constraint to this edge here that it has to be like 5 millimeters. Same for this one here and the same for that one. So it's fully constrained, and then I can simply fix this hexagon at its place. When it comes to pattern, there's a very awesome tool here in the Sketcher workbench, and that's the Move Array Transform. This is actually really powerful. What it does, if you select your sketch and then click on this tool, Move Array Transform, then here on the right, you can set two parameters, copies. So let's do like 2 copies and the amount of rows. What it means, it will create, in this case, 2 copies and 4 rows of those copies. And let's simply demonstrate it. You can also set apply equal constraints. So let's do that. Yeah. By holding Control, I can have a fixed step size again. The first click is for the rows. So I click again. And then the second click is for the columns. And you can already see it's creating all those copies on the X and Y axis. And you can do whatever you want. You can create a complex pattern this way in no time. And that's super cool. And here it looks a bit messy. Those are all the constraints. Let's remove that again. All right, back in the part design workbench. Now with this shape, I added a pocket operation, which creates this hole. And I also set the position, the placement of it under attachment position, minus 38, 10 on the Z-axis. And the length of the pocket is 12 millimeter. Then let's have a look at this pattern. Here on the top, I created this pattern with a linear pattern operation. And if I click on it, here we can see on the right this menu. We first have to select the pocket operation and then click on linear pattern. It's also selecting here the pocket 001, which is this one here. And then we can define here the offset. So it's 12.23 millimeter. And how often this pocket should appear. It can be like 10, it can be like 5. About the edges, the rounded edges, this is the fillet operation. So let's cancel this for a moment. It's here on the top. It's with this rounded edge. And it works like, again, we need to select the latest step in our hierarchy. So that's linear pattern. Then if we click on fillet, it will create this fillet object, and there we simply select the edges we want to round off. So in my case, those are the edges. You simply select them by holding down Control, and then you can set here the radius, how round they should be. Now, because this shape was padded in this direction, we can see here on the left the sketch. So I won't be able to round off this corner here, this edge. I could do that by adjust the padding direction. So if I go to my padding object in the hierarchy, let's first cancel this. And then I double click on the pad object. There's an option which says symmetric to plane. If I click on it, it will equally pad the sketch to both sides, and then I'm able to round those edges on both sides. This also can angle up the edges, so if I select this face and simply click on it, then it will add some additional geometry. It's like a bevel tool. Then we have here also the mirror tool. So let's check that out. I mean, it does what it says. Let's select this object first, select the mirroring, and then we have to select on which face or on which plane it should be mirrored. Let's go with the YZ plane. Okay, it was the wrong option here. So here you go. You can mirror your object. So that's pretty cool if you have something symmetrical. So far, we haven't talked about the part workbench, and I haven't used it to create the mount. In general, you use the part designer always want to do some parametric modeling, which means you want to have accurate measurements, accurate values with constraints. The part workbench is different. You use it when you are working with several solid objects, which also can be imported. For example, you have something created in Blender, which is maybe some organic 3D object, and you want to combine it with some object which you have created with a part design, and you want to do some basic Boolean operation. You can do that here in the part workbench. You can also create different kinds of solids here, like spheres and cylinders. In the part design workbench, you're always focusing on one body. Now, in general, the Boolean operations in the part workbench are a bit easier to use. You can use them also with your bodies, which you have created in the part designer if you have several of them. But as you can also see, you have the Boolean operation also here in the part designer. So to get a feeling about the differences, let's simply do an example. So here in the part workbench, I will create a cube and a cylinder. So that's super easy and simple. And then I will select the cube, select the Boolean operation, select the cylinder, and I will set it to difference. And there we go. And that's super easy and super fast. Now, I can also do it with this body. Let's create a 3D object out of it first. Go back to the part designer, add some padding to it, 50 or 40 millimeter. Oh yeah, we haven't created a sketch here. So let's create a hexagon like this. And this should create it. Yeah. And then we go back to this part workbench. And this is now our solid object. And we want to do a difference operation to it. So let's select the cut. And there we go. In the part designer, this is more complicated, but we can try to do the same in the part designer. So let's reverse it. All right, like this. And now we are in the part designer, and I'm going to select Boolean operation. Ah, there we can see the difference. I can only perform this operation between two bodies, not between another solid object, which has been not created through parametric modeling. If I create now another body, create another body. Okay, let's delete this. Another body, another sketch, same plane, and a circle. I add some padding to it, and I now can use the Boolean operation. So it will automatically select the other body. Cut operation. All right. So here we have a very fat Pac-Man. I think he has eaten too much. So that's it for this video. I hope you could learn something from it, and I will see you in the next one.